EC department at LJ Institute of Engineering and Technology. Welcome to the session of satellite communication. In the last session from unit number 8, that is satellite link design, we have designed a link for downlink and we have calculated a link budget equation, that is a carrier to noise power ratio. Right? In today's session, we will cover the uplink design, that is link power budget equation for uplink. We will design for a specific system, that is carrier to noise power, designing a specific system. Then we are going to follow a satellite communication link design procedure and we will see one example of link budget. Right? Before starting the uplink design, what we have done in the downlink design? In downlink design, we have considered output backoff, but over here in uplink design, we will consider input backoff. This is the only difference. Apart from that, in uplink design, this is my transmitting antenna. It's going to be transmit a signal to the satellite, right? So this signal is going to be transmitted by the earth station and received by a satellite. So this is called the uplink, right? We are going to design a link power budget for the uplink. So what is the procedure? As this uplink design is much easier than the downlink. How? Because in this we are simply need a carrier power which must be presented at satellite transponder, and it uses a much higher power transmitter at the earth station. Alright, we are going to transmit the high power with the help of high power transmitter, which can be used, which can't be used at the satellite because it will be a bulkier and it will also increase the cost of our satellite. So we are able to transmit the high power at the transmitting side, which is on the earth station, right? Apart from that, the cost of the transmitter is going to be increased. Why? Because we are going to transmit the high power gain, high power amplifier. So it has a high gain, so it will ultimately increase the cost of my system compared to the cost of received equipment. Third point, the earth station transmitter power is set by a power level which is required at the input to the transponder. Right? What are different types of transponder that we have discussed? That is single conversion, double conversion. Single conversion means we are going to do up conversion and down conversion only one time. That is single conversion. If we are going to do it twice, it is called the double conversion. So analysis of this uplink, which requires a calculation of power level. How much amount of power is present in the transponder? Alright, so that we can calculate the uplink carrier to noise power. So the link equation which is used to be calculated to make this calculation. And over here, to distinguish between the carrier to noise power for uplink and downlink, we are simply placing UP. UP stands for uplink, right? If we are going to calculate for downlink, we are going to simply denote it with the DL, that is downlink, or DL, right? Now, when we are going to consider the frequency and the microwave bands, we need to consider that at a frequency which is above 10 GHz, the propagation disturbance in the form of fading in the brain, which cause a received power to decrease. While we are dealing with the frequency above 10 GHz, we need to consider the loss which is caused due to the fading in the brain. Right? Next point is, due to that, my carrier power will going to decrease. So it will ultimately cause a fall in the carrier to noise power, because carrier power is going to be decreased, noise is increased. So overall this quantity is going to be decreased. Right? Now, for designing a specified carrier to noise power, what we need to do is there are a number of system inputs, right? And we know that carrier to noise power for each and every system. So how to calculate the design for specific carrier to noise power? The first is when more than one carrier to noise ratio is present in the link, we need to first individually calculate carrier to noise power and then simply reciprocal it, right? How? The overall carrier to noise power, which is given as C by N in bracket O. O stands for overall, right? So first we are going to calculate the carrier to noise power for first system in the link, then second system up to N system. And we are going to make the reciprocal of that overall answer, right? So we can say that this is the reciprocal C by N formula. Apart from that, this carrier to noise ratio must be a linear ratio, not in decibel, right? Such that we are able to calculate with the help of this equation, right? But if it is in dB, then how to calculate it? C by N in bracket, it is O, that is overall, is equals to C dB watt. That means my carrier power in dB watt minus 10 log base 10 N1 plus N2 plus N3 up to Nn. But these quantities are in dB, right? As my noise power is in denominator, we are subtracting that quantity because we are going to represent it in the form of decibel, right? So at the receiving side, it will yields at carrier to noise for overall. So the it is a combination of transponder and the earth station carrier to noise ratio, right? Now, a satellite communication link design procedure. What are the different steps that we need to follow for the satellite communication link design? First, we need to determine what is our frequency band. As we have discussed already that there are different types of microwave bands like L, S, C, X, A, K, K, which have existing frequency like 1 to 2 GHz, 2 to 4, 4 to 8, 8 to 12, 12 to 18, 18 to 20, 6.4 and 26.4 to 40 GHz respectively for all the bands, right? So based on which frequency band we are going to use is depends. Why? Because at higher frequency we know that it may impact my overall carrier power, right? So first portion is determine the frequency band. Second, what are different communication parameters for the satellite? We are just estimating any values which we don't know, right? Third, starting at the transmitting earth station, we will establish an uplink budget and transponder noise power. Why? Because to calculate the carrier to noise power, we must know what is my value of carrier power and what is the value of noise power, transponder noise power, right? To calculate carrier to noise for uplink, or you can say for downlink. And we are going to determine the parameter of transmitting and receiving earth station. After that, we will find what is the output power of transponder based on the gain. Whether I am going to calculate for uplink or downlink. If it is for uplink, we need to consider input backoff. When we are going to deal with the downlink, we need to consider for the output backoff, right? As we are going to establish for the downlink, we need to consider carrier power and the noise power for the receiving earth station. If we are dealing with the uplink, we need to consider carrier power and noise power for transmitter, or you can say transmitting earth station, right? So we are first calculating the carrier to noise power for downlink, and we will calculate the carrier to noise power for the overall system, right? Second thing, as we are dealing with the analog communication, we need to consider carrier to signal to noise power. If it is digital, then energy, it is EB upon NZ. Okay, that is beat error rate in the baseband channel, right? We will evaluate this overall result and we will compare with the specific requirement. So these are the steps to follow satellite link design procedure. Now, as we need to first consider what is my frequency band and which will affect my carrier power. Why? Because we need to determine what is the propagation condition under which a link must operate. So we are calculating the outage time for uplink as well as for the downlink, and we will redesign the system by changing the some parameter. Because this link budget will provide a simply changing the parameter, and we are able to recalculate all the carrier power and the receive power as well as the noise power, right? Now I am going to give you one example of link budget. To complete the link budget for satellite system with the parameter which is given as below. For link budget calculation, we need to understand what is the difference while calculating for uplink and for downlink. First, for uplink, for earth station transmitting output power at saturation is 2000 watt. Similarly, for TX output power station, it's 10 dB watt. Now back of loss, 3 dB for uplink and 0.1 dB for downlink. Okay. Third, feeder loss, 4 dB for uplink and 0.5 dB for downlink, which is less compared to the uplink. Earth station antenna gain, you can compare easily. My gain of transmitting earth station transmitting antenna is 64 dB, which is higher, or I can say double than the gain of my receiving antenna. Why? As we have discussed, we are able to transmit a high power at the earth station, and we cannot able to that fixed a high power amplifier on the satellite, because it will cause a cost of the satellite to increase and my satellite becomes bulkier. So the gain of receiving antenna will be 30.8, which is the half than the gain of transmitted antenna. As we can compare for the atmospheric absorption, which is 0.6 dB for uplink and 0.4, almost it is nearer, right? Then satellite receiver, that is gain to temperature, that is G by T ratio that we have discussed already in chapter number 8. That is G gain to temperature ratio is minus 5.3 dB per Kelvin, and over there it is 62 dB, right? As we can consider the satellite branching and feeder loss for uplink, it is 0 dB. But when we are going to deal with the downlink, so we need to consider the earth station branching and feeder loss. It is approximately near to 0 dB. Then what is the beat rate? For beat rate, it is for uplink, it's 120 Mbps. And which modulation that we are going to use is 8 PSK. Phase shift key, phase shift key, right? And the free space path loss, at 14 gigahertz, that is 4 pi r mod lambda, that is 206.5 dB. Alright, and for the downlink its value is 205.60, which is almost nearer to the uplink. Right? So this is the example to calculate a link budget, and which gives the complete difference between uplink and the downlink. Then how to calculate a link budget separately for the uplink and for the downlink. Alright. So over here the link budget calculation for uplink and downlink is finished. Still, if you have any question, you can ask me at any time on my email ID. In the next session, we will see how to calculate a combined carrier to noise power. That means a combination of uplink and downlink at the same time. Right? Anytime. If you have any question, you can ask me. Thank you for your attention.